So today we're going to start on our first actual project, all right, which is going to be the widget. All right, what's a widget?
Jack that widgets.
A widget's just a thing. Okay, it doesn't necessarily do anything. It's just something. All right, and so what we have is we have some 2-inch by, I don't know, 1/4 inch aluminum. And so we're going to make our widget out of this, and it's going to look something like this. So I sent actually I posted a drawing on Moodle that has this drawing. Some of the dimensions are appended, some of them are not. You should be able to extract those. And so basically what it is that we have a center hole. All right. Dimensions of our block should be roughly 2-inch by 2-inch. All right. Well, one of these is a given because it's the natural sides, and then the other sides are going to be what? They're going to be saw cut. Catch. You get bonus points for today. And we got it on camera too.
All right.
And so when you cut this, you want to cut it just a little bit long so that you can then bring it into our 2 inches. All right. So this hole is going to be located centrally. All right. This will be our datum point. And this is actually on the drawing itself. There's a text on there showing what the datum point is. And then each of these is a tapped hole for a different tap size. All right. So what we're going to have to do is we're going to have to cut off our piece of material. We're going to have to lay out our piece of material, mark all of these holes. We'll center punch the holes. We'll drill the holes with an appropriate size tap drill, and then we want to tap each of those holes. And ideally, we want to have our tapped holes so that they are perpendicular to the surface and not at an angle. All right. So questions over what the assignment's going to be. So let's all go grab a pair of glasses, and then we'll walk through how this works. Going on this report. Okay, so first thing we're going to do is I'm going to set my dimension here on this. A couple different ways that I can set it. Quick and easy way is what? I can just set it actually on the dimension there and tighten it. All right, and that's going to get me real close. If I want to be really close, I can take a caliper and I can use the rear end of it as it slides out to set my 2 inches. All right, then what I'm going to do is I'm going to set it on here. I'm going to use a scribe, and this one's already done. And I'll make my mark. All right, and then I'm going to take this, I'm going to come at 90. I'm going to line up. And I'm going to make my mark. Okay? Now, why didn't I use a Sharpie?
It's thick.
Yeah, because even with the real thin, fine ones, they're still pretty thick. All right? Here I've got a really good sharp edge. All right? Then I'm going to go ahead and transfer that edge here. And what I'm doing is I'm holding this up tight and then transferring my mark. All right. Now, on this particular one, I went ahead and laid out this so that I didn't have to wait for the Daikin to dry. So, blue layout fluid. All right. Whatever you touch this on, it's going to be stained for life. So please, please, please do not take this out of this room. Because if you do it on one of those tables over there, it's there for my lifetime. Okay, and I plan on living another 50 years. All right, so all I'm going to do is I'm just going to spread this on there, all right, and get my stuff. Onward, Christian soldiers. Cutoff saw. It is pneumatically operated. Come on around here so you can see. So the way that this works is that it has a pneumatic cylinder here, all right, that controls the rate of fall, all right. And so I have a little switch here that when it's out at a 90 degree means it's off. And then if I turn it in line, now the air is actually traveling to there. I have this little jobby right here. If I turn it all the way down, it stops the airflow. As I open it up, I can control how quickly this falls. All right, and that's way too quick for what we want. All right. So there's a fine line between moving too fast and moving too slow. If I'm coming down too slow, what I'm doing is I'm getting excess wear on the teeth of the blade. All right. If I come down too fast, number one, on aluminum it's not going to be a problem. If I were trying to cut steel, it can be problematic because the blade can actually catch and break. It could catch and break in aluminum, but it's much less likely. All right. But what happens is the more force that's being applied, if the teeth aren't able to clear it fast enough, what happens is the blade will start to walk out, and so my cut then becomes like this, because it'll start cutting here, and then it will, and so I wind up with a cut that's not square. All right. Now this is set up, and it cuts pretty well. Shut that. So what I want to do is I'm going to open that up, and then I'll put my piece in. Now, I marked the top of this because it's a little more efficient to cut. It's going to battle me all the way. It's a little more efficient and easier to cut it on its end. All right. I could lay it over and I could cut it on the flat. All right. But it works a little better if I actually will set it up on its edge. And what I'm going to do is I'm just going to get this close, and I'm going to lightly clamp it, and I'm going to bring the blade down so that I'm in close proximity and I can actually see where I'm at. And for whatever reason, so if this isn't sitting squarely in there, guess what happens? Your cut's not going to be square. Not enough room. All right, so what I'm going to do, what side of the line do I want to cut on? That side, right? Because my line marks where my 2 inches is. So I'm just going to get it close, and then, so I've got it pretty close. All right, when it's time, I'm going to turn it on, and I'm going to just lightly release this. That's about the rate of descent that we want. I can go faster, but again, the faster that it goes, the more the teeth are bogging down and the blade has a tendency to walk out. Then when it cuts all the way through, it will shut off. All right, and now I have my part, and then I'm going to take a file and I'm going to remove the burrs off of the sides. All right, for most of you, you'll have 2 cut sides, and so you're going to remove burrs off of both sides. All right, and we'll talk about actual finishing of this at a later date. But for now I have a piece that I can actually lay out. So now I'm just going to do this. I'm going to lock that out. Now as soon as I release this, what's going to happen? It's going to go bloop. It's going to fall off. So somebody grab that, please. All right. And then just pull it out of there. All right, questions over that? All right, let's go back in here. Having a datum. Where's the datum at? What is the datum?
It's your zero.
It's my zero. What does that mean?
Where you're taking all the measurements from.
Right. So when we do this, all right, there are two different ways of laying things out, right? I can do absolute or I can do incremental coordinates, all right? And so typically I like to use absolute, though in actuality there are some absolute and there are some incremental coordinates that I have put on this, all right? And I did that purposely. Usually I do absolute. I pick one point and everything is based off of that point. All right? And the reason I do that is that if I get one slightly off, usually it's within tolerance. But if I do incrementalism, what's the difference between absolute and incremental?
You're judging dimensions off of one another.
Right. So let's say that, you know, I do absolute coordinates to the center hole and then I do incremental or relative coordinates from that hole. Well, this hole is slightly off, right? And then I'm doing measurements from this hole to the next. What happens? I get an increase in error. All right. So I like to use absolute. That way, if I get one that's slightly off, usually it's still within tolerance and the part's still usable. If I use relative, all right, or incremental, what happens is my error starts to build with each hole. All right. So if I make an error on one hole, and then I make an error on another hole, it just keeps adding up, and so my error gets larger and larger. So you'll want to mark in some fashion what corner you're going to use as your datum point. All right, most of the coordinates that I have on there are set to absolute. There are a couple that are incremental. Can you go in and pull absolute values off of the drawing? Absolutely, you can. All right, and if I were doing this, that's probably what I would do. All right, so how do I lay this out? Well, I know that the center line, the center hole is 1 inch. So I would set 1 inch on this. If I were going to be really accurate, which I would expect you to do, I would go ahead and set 1 inch on the back end of a dial caliper and set this to be 1 inch. All right, and so I am going to use this corner as my absolute, and all I'm going to do is I'm going to mark the center, and then I'm going to mark the center. Okay, so there's my center hole. All right, why do I have a little dip in it? So when I laid it out, I had the little dip there down. All right. Now, is it going to stop me from getting where I want it? No. But next thing I'm going to do is I'm going to take what's called an automatic center punch. I'm going to center that on that hole, and then I'm just going to press straight down, and it will place a mark. I really need my glasses to see that because it got fuzzy all of a sudden. Wait till you guys are 50. Everything will be fuzzy. All right, so there's my center hole. What do I do next? We had this the other day. What did we do? We're going to spot drill, right? So we're going to take that center drill, and I'll get those out, and we're going to center drill it, all right? But we're going to lay out all of our holes, and then what I would recommend is that while you have all those lined up, go ahead and center drill all of those, because you don't have to change drill bits, all right? And then you're going to figure out what size drill I need for a particular tap size. All right, so there are 7 holes total. Center hole, I think, is number 7. Number 1 starts here, and they work their way around. And they are called out on the drawing. It tells you exactly what it should be. So how do I find out? Well, actually, what is a tap drill? Not you, not you, and not you. What is a tap drill? No.
I think it's a certain difference in size. It's slightly smaller than the size
Yes.
hole that you want. So then when you thread it,
Yep, yep. Come over here. Let's.
Let's keep it on this time.
Bring it on up so you can actually see. All right, so when I drill this hole, let me do a cross section here. So we've got our piece here, and so we're going to drill a hole. All right, now on the outside of that hole, there's going to be threads, right, that are cut in. And yes, I realize I am not an artiste. All right, so a tap drill basically cuts this diameter right here, this internal diameter, all right, so that when we go in with a tap, which actually it cuts the actual threads itself, this is already gone. And so all that tap is doing is it's following this hole, and as we work it through, it's incrementally cutting each of these grooves. Okay, so tap drill, super important. All right, the average tap drill leaves 75% engagement of the threads. All right, give or take a percent. All right, and so what that means is that 75% engagement. All right, so what that means is that if we had 100% engagement, we'd never be able to force the thing through there, right? Because all the edges are touching. Well, 75% leaves a 25% basically margin for things to move. All right. So where do we find this information? How do I know what size tap drill to use for, say, a 1/4-20? Looking. How do I know what size tap drill I should use for a 1/4-20? I need the Jeopardy song. Okay? Who does know besides the three?
Is there a data sheet for it?
There is a sheet. Let's go over here. There's a sheet for everything. Okay, so hanging right here on the side, all right, is the decimal equivalent and a tap drill sheet, all right, or chart. All right, every shop will have one. All right, I will actually post one on the Moodle as well, so that you have something that you can look at without actually having to be right here. All right, but basically what I'm going to do is I'm going to come over here with this tap drill sizes, and then I'm going to find over on this far left-hand column the actual thread that I'm looking for. So in this case, I'm looking for a 1/4-20, and they go from smallest to biggest. All right, so we start with a 0.80, I think. I can't really see. And we go down, oh, and the biggest here is a 12.28. Well, so I got to go to the next column. All right, and there we go, 1/4-20. And then in the column, it says drill. That's the tap drill size. And in this case, it's a number 7. All right, so who's saying, well, gee, what size is the number 7? Somebody is. Okay, so drills come in 3 different measurement systems, right? So we have the standard fractional decimal that we're all familiar with, right? 1/4 inch, 5/16, 3/32, so forth and so on. Not very many of those are actual tap drill sizes. All right, so we also have what's called a number drill and we have a letter drill. All right, so in our particular case here, we have our standard fractionals here, all right, by 64ths up to 1/2 inch. Over here we have letter drills, all right, and it goes A through Z, and Z being the smallest, or excuse me, A being the smallest, Z being the biggest. And then we have the number drills, all right. And so typical number drills go 1 through 60. And then there's also an extended set that is 61 through 80, and those are very, very tiny. So down here we've got the number 80, which is number 60, which is 40,006.040. It's tiny, okay? So the way these are set up is so that when they first started standardizing screw pitches in mid-1900s, 1920s, 1930s, all right, prior to that, every manufacturer had their own screw pitches that they made, and that's just what it was. There was no standardization. So if you went from one place to another, they were using a different type of screw, a different type of thread, the whole 9 yards, okay? So once they started standardizing those, you know, we were already using the 64 system for drill bits, and then what they were finding is that, you know, if we're going to have a standard across the board for screws and thread engagement and all that good stuff, then we needed to have drill sizes that fell in between the standard 64s, okay? And so that's how the number drills and the letter drills were born, in that once we started standardizing that, we realized that, hey, in order to hit this standard, all right, we've got to have some drills that fall on outside of the normal fractional measurements, okay? So there we go. So how does that process work? All right, we look it up on there. We're going to get out the appropriate drill, all right? Hopefully we have already pre-drilled our holes, all right? And I will tell you that some of the holes that we're going to be tapping are fairly small. An 832 is the smallest one, all right? And an 832, our tap drill size is a number 29, which is 136 thousandths. It's fairly small. That's it. So why am I saying that? Why do I care? Because if I pre-drilled with this, does anybody see the problem? Okay, so before you start doing your spot drilling, look at what it's supposed to be. Okay, so we have an assortment here. There are actually 2 little containers. And so for that one, I want to use the little bitty guy, right? Do be careful, because when they're little bitty, they break easily. While we're drilling, okay, if you put brute force on one of these, you can and will break a drill, all right, especially these smaller ones, all right? And so that means that we've got to go find another drill, and then you're probably going to be out of luck for the rest of the day. All right? I have some replacements, but I don't have a whole lot. So when you're drilling, feel what the drill is doing. Don't muscle it, just feel it. All right? You should be able to feel the drill cutting. Okay? Questions? No questions? All right, let's get started. All right, so today we're going to cover basic tapping, and so things that we'll need is Tap Magic, which is a lubricant. We will need some type of tap driver, all right, and so this is the most common. Not really a fan of these. This is another version. I actually like these better than these. And then my all-time favorite, and I think this is actually a shop-made one, but I really like this one because it gives me a lot of control and a lot of feel. And then of course we need a tap, and so a tap is basically just a piece of high-speed steel or carbide. Let it focus, maybe. Oh, come on, you silly thing. Anyhow, so you got threads that are cut along this, and so we'll stick this in a hole that has already been cut by a tap drill, and we talked about that in the previous video. And I want to keep this straight up and down as I turn it in a clockwise direction for right-handed taps, and then there are such a thing as left-handed taps. And so I'll just go ahead and I'll show you real quick. This is a 1/4-28, and for our project 1 we start off in hole number 1 with a 1/4-28. So let me get you dialed in there and I'll go through this. There it goes. Alright, so what I'm going to do is just going to put a little bit of tap magic. When I say a little bit, I mean a couple drops. I'm going to set it in the hole, and then I'm just going to, and I like to kind of step back in an oblique angle and look and try to get the tap started straight. If you do not get the tap started straight, number 1, your hole is not going to tap straight, and number 2, you can actually bind up your tap and break it. Alright, and so what I'm doing here, and hopefully you can see the little chips curling up off of this, is so typically what I'll do is I'll go, I don't know, a turn, maybe a little more, and then I'll back it back almost a full turn, and that breaks the chip off and allows me to keep tapping without breaking. And this one's already almost through. And so what I'm doing is I'm putting equal pressure on both sides. Alright, and the easiest way to break a tap is to try to do one of these numbers, and so you're getting pressure on one side instead of the other, and you'll snap a tap right off. And it's very easy to break a 1/4-inch tap. I've done many in my younger days. I don't do them quite so much anymore, except when I'm tapping difficult materials. Aluminum can be very difficult to tap because it tends to be a little bit gummy, especially 60-61, especially in our smaller size taps. Alright, there we go. Now it's all the way through, and I'm just turning it, and then when I turn it back out, I want to use, again, I want to try to use equal pressure, especially on smaller taps, because it's real easy to break them. Alright, and so there we go, and we can see that I've got this whole thing is just full of chips. Alright, and so I'd wipe those out and then go on to the next. Alright, something else I can do, and I just made these up for the class today, is what's basically a little tap guide. And so what that does is it allows me to set the tap in there, and the tap will sit relatively straight to the workpiece. And so that way, especially when you're first starting out, it's real easy to wind up with a tap being held, you know, at a fairly substantial angle. And it'll actually start like that, but it's not going to straighten out. And so essentially what's going to happen is you're going to get to a point where the tap can't do any more, and then you're going to break it off, and then you've pretty much wasted that piece, especially on these very small taps, because they're very, very difficult to get out, especially in aluminum. All right.